Hi, I'm Nandini Mukherjee, and I'd like to let you know a little bit about neuroplasticity, especially how it relates to learning. First off, neuroplasticity refers to the brain's ability to reorganize synaptic connections after learning, experience, or injury. Neuroplasticity is affected by both genetic and environmental factors. Our brain's synaptic growth is concentrated early on in life. While our ability to form new connections in speech, hearing, and sight abruptly decrease after childhood, our cognitive powers taper off much more gradually, though still significantly. Wouldn't it be amazing if we could continue to learn and make new connections in adulthood as rapidly as we had in our youth? The hippocampus plays an important role in consolidating information, which results in learning. Hippocampal neurogenesis leads to the creation of new memories. Cognitive decline presents itself similarly to hippocampal damage. A study on London taxicab drivers showed that learning new city routes, which is spatial learning, results in growth in the posterior hippocampi. The amount of growth increased the longer they had been driving. While gray matter density and cortical thickness play a role in learning, let's focus on lower level changes through CSPGs. Chondroitin sulfate proteoglycans, or CSPGs, are structural components secreted naturally by cells that accumulate over time. As part of the extracellular matrix, CSPGs are involved with adhesion, migration, and interaction of cells. They inhibit axon regeneration, which is a problem, especially after brain or spinal injuries. The formation of CSPGs inhibits shifts in ocular dominance because they prevent axon growth. If a child's dominant eye is damaged, the other eye will compensate and become dominant, but this change does not occur in adults. Similarly, CSPGs prevent the ability to relearn or learn new motor skills after loss of limb function. Removing CSPGs, or preventing them from growing in the first place, extends a critical period where learning can still occur. Initially, any reparative therapy using CSPG inhibitors would be reserved for people with neural damage from disease. With better understanding of CSPG's role in cognition, perhaps inhibitors could serve as cognitive stimulants. While certain regions of the brain do experience deterioration with age, the brain does still continue to grow and learn well through adulthood. As we learn more about learning and how our brain functions, we will gain insight on how to learn even more. Thank you.